Welcome back. We have talked about conversions now, dimensional analysis, unit conversions, whatever you want to call them. And we've put together a system that's fairly methodical about how to set up those conversions. And what we're going to do today is we are going to talk about a specific type of conversion, which are called unit prefixes. And these unit prefixes you're going to see in life all the time when you see a water bottle and it's got a volume in milliliters. That milli is a prefix to the word liter that you can actually use in front of any unit you want. Not just in front of liters, you can use it in front of grams, you can use it in front of seconds, you can use it in front of calculators if you could have a milli calculator. And what we're going to see is how can we use those unit conversions, or those unit prefixes, I should say, in all of our different ways. How can we convert between them, understand what they mean? And part of it goes back to thinking about what do we do when we want to change the size of a unit in English language, in English units. And so if we have something that's about an inch long, yay big, and we want to have something that's bigger, what's the next thing up from an inch, right? It's about a foot. And we know that there are 12 inches in 1 foot, which is great. I mean, it's just a number. But it means if you want to convert between feet and inches, you got to either multiply by 12 or divide by 12. And so if you have, like 10 inches, it's not equal to 1 foot, it's equal to 10/12ths of a foot, 5/6 of a foot, whatever that is. You have to put it into a calculator and find the decimal, unless you happen to know those off the top of your head. Now, if you want something larger than a foot, you're probably going to go for a yard. Now, in a world that was consistent, just for consistency, you'd go ahead and make a yard 12 feet. But we know that's not what it is. A yard is 3 feet. And so if you want to get from inches to feet to yard, one time you go from 12 and one time you use a 3. And it's not very consistent, but it's what we got. Now, if you want something larger than a yard, wouldn't it make sense to have something that was, somewhere between 3 and 12 bigger? No, right? Because we go from a yard, we go to a mile. And a mile in yards, I always have to look up this number, is 1,760 yards. I mean, these numbers are fairly random looking. There is reason behind them. You can look up the history of these numbers and where they came from. But they are fairly random, and they make conversions fairly difficult because you have to do a different type of conversion every time. So a while back ago, people got together and they said, hey, let's try to set up a system of units where the conversions make, sense, and see what happens and what can we do. So they developed the metric system, and you're probably familiar with the metric system. We talked about it a little bit in one of the previous videos, where a meter is about 3 feet long. And then they said, hey, how would we change the size of a meter? And they said, let's put some prefixes in front of it to change it. And so you probably are also familiar with a millimeter. A millimeter is a very, very small distance. You probably can't even see that my fingers are separated. About the height of an ant is a millimeter. But if you want something larger than a millimeter, you might go ahead and get a decimeter. So a decimeter is 10 millimeters. I'm sorry, centimeter. My apologies. A centimeter is 10 millimeters. And, you can see what's coming next. If you want something larger than that, you're going to go to a decimeter. Now, in the English system, right, there's another random number here. But here, hey, guess what? The number is 10. 1 decimeter is 10 centimeters. And if you want to go something bigger than that, you're going to get to the meter. And that is, lo and behold, 10 decimeters. And so you can see all of our units here are related by a factor of 10. And why is a factor of 10 cool? Well, if you want to change 123 from, centimeters into millimeters, what you're going to do is you're going to multiply by 10. And so you get 1230 millimeters. And we'll see how to do that in a very methodical way later. So you get 1,230 millimeters. And you'll notice something is the numbers here are the same. And what you're doing is just moving the decimal back and forth when you convert using unit prefixes, which is great. It makes it really easy to understand whether you're doing it correctly because these numbers don't keep changing. You're not multiplying by 3 and dividing by 1,760, all these fairly random numbers. Now, if we tried to have a unit that went every 10 for all the different things we do in science, it would be crazy, and we'd end up with like 40 or 50 different unit prefixes, and that's hard to keep track of. So at some point they said, okay, for common size things that we run across on a daily basis, let's have lots of little tiny different things. We have millimeters and centimeters and decimeters, milligrams and centigrams and decigrams. But for things that start to get to different scales, let's go by thousands instead of by tens. And so if you want something larger than that, you're going to say that 1 kilometer is equal to 1,000 meters. But again, since it's 1,000, you're just moving the decimal point 3 spaces instead of 1 space. You're still going to end up with the same numbers, but the decimal point has moved. So it's a very nice, very tidy little system. What I need you to know is I need you to know all of the different prefixes that we might commonly run across when we're doing science. And they are in this list here. Starting at the top, there is tera. Now you might be familiar with this one because if you go out and buy a hard drive nowadays, you might buy a terabyte or 2 terabytes or 8 terabytes or whatever it is to store all those cat videos that you take. And that's a big number. The big number, terabyte, is about 10 to the 12th. Now, it turns out there's a slight difference between computer science tera and scientist tera, but it's about 10 to the 12th. For a scientist, it's exactly 10 to the 12th. It's a huge number. That's a lot of little bytes in there. And if you look at the memory in your computer, you're probably measuring the memory in your computer or the memory in your phone in gigabytes. You might have 128 gigabytes of memory in your phone if you're lucky, or if you've got only 16 gigabytes, you probably have to manage things a little bit better. So you're measuring those in gigabytes. And giga, anytime you put giga in front of anything, it means you've got 10 to the 9th of them. So I can actually put giga in front of pandas. And if I had giga pandas, that means I've got 10 to the 9th pandas. I don't know what you do with that many pandas, but that's what it means. Giga in front of anything means I've got 10 to the 9th. And 10 to the 9th is a billion. So I've got a billion of them. Mega, you've probably heard that too. Mega means 10 to the 6th or a million. And again, I can put that in front of any unit I want. I can have megagrams, I can have megaseconds, I can have mega dogs. I don't know what you do with a million dogs, but you could. Right, so whatever you want. These prefixes are very, very flexible, and you can use them in any sort of way. Kilo, we just talked about a kilometer, which is 1,000 meters. Kilo is 1,000 of anything. And you'll notice that, I wish they'd been a little more consistent, that all these big numbers, 10 to the 12th, 10 to the 9th, 10 to the 6th, have capital letters. Unfortunately, that is except for kilo, which is a lowercase letter. But you have to do the capitalization correctly, because as we'll see in a moment, there's a capital M and a lowercase m, and they mean very, very different things. For things that make a unit smaller is deci. We talked about that. Deci is a tenth. So if you have a decimeter, it's a tenth of a meter. If you have a decigram, it's a tenth of a gram. Centi is a hundredth. Centimeter is a hundredth of a meter. Milli is a thousandth. A milliliter is a thousandth of a liter. 10 to the minus third if you want to represent it in scientific notation. Then we get to other ones that you've probably heard maybe, but you aren't as familiar with. Micro. You've probably heard of micro things. I mean, even just the use of the term micro brews, if they're talking about very small batches of beers that are cooked up. Micro is a very small number. It means 10 to the minus 6. It means 1/1,000,000th of something. So a micrometer is 1/1,000,000th of a meter. And it's hard to imagine a number that small, but we need to be able to use numbers like that in chemistry and science all the time, because we measure things that are on the size of molecules and atoms, which are less than a micrometer in size. Crazy stuff. Nano, you've probably heard of nanotechnology. People talk about that. It's kind of a buzzword in many different places. What is nano? It's 10 to the minus 9th. That means you're looking at a billionth of something. And again, you can put it in front of any unit. You can have a nanometer, you can have a nanogram, you can have a nanosecond, and you could have nano chickens. I don't know what you'd do with a millionth of a chicken. It'd be a very small amount of chicken. Wouldn't fill you up very much. But you could. That's the thing about these prefixes. You can put them in front of anything you want. And all they do is modify it to say, oh, I've got a millionth of that, or I've got a billionth of that. And then down here at the very bottom, and it's not the actual very bottom, it's just the very bottom for this class, is pico, which is 10 to the minus 12th. Very, very small numbers, 10 to the minus 12th of something. If you're trying to memorize these, and I encourage you to, I really encourage you to memorize these things. The mnemonic that I think works really well is if you're going down from tera down to nano, you have the great mighty king died choking on mini metal nails. Okay, so you can actually memorize that just by using the mnemonic down there. You'd still have to keep track of the numbers, but if you look at the numbers, if you can remember, this guy is 10 to the 12th. Down here for giga, mega, and kilo, they go by 3s. So it goes 12, 9, 6, 3. Down here in deci, centi, and milli, it goes by 1s, and so that one just requires a little more memorization. But down here in these last 3, from micro, nano, and pico, they again go by 3s, 6, 9, and 12. So we're going to use these all the time. So you definitely need to be familiar with them, be comfortable with using them, and I'll show you how to do conversions with them in just a moment. So we can put them on SI units, like I said, meters, grams, all of those seconds. We can do all those things. But what's the point of using these prefixes? And the point of using these prefixes is, again, back to our understanding of numbers that we talked about. We can very easily picture numbers between 1 and 1,000, and we have a hard time picturing numbers outside of that range. And you'll notice that those prefixes are every 1,000 or so, which allows us to always represent a number in a way that we can picture the number and then think about the prefix. So our goal when we're using the prefixes is to get a number between 1 and 1,000 in front of our measurement. So you wouldn't go ahead and say, oh, I'm going to take a measurement and I'm going to weigh myself and figure out that I weigh 65,317,000 milligrams. It doesn't make a lot of sense to do that because now you've got this number of 65 million. It's correct. It's not a wrong way of measuring. It's just not a useful way of measuring, and these prefixes are designed to be useful. So even better, we'd report ourselves as 65.317 kilograms. Now we've got a number between 1 and 1,000. We can kind of picture 65 in our head, and then if we know what a kilogram is, we just say, oh, we've got 65 of those. So we're going to try to use those kind of things, and if I ask you to ever write something in a proper way using unit prefixes, you want that number to be between 1 and 1,000. And again, we'll talk about how to convert between those in just a moment. So good reporting of numbers: 15 milliliters, 100 kilometers, 42.82 seconds. Bad reporting was, say, 0.00329 meters. You don't want these very, very small numbers, or 10,300 milliliters, or 1,000,000 microseconds. You don't want these very large numbers in there. But they're, again, just as a reminder, they're just conversion factors. We can use them with any unit that we want, not just the SI units, not just grams and liters and seconds and things like that. We can use them literally on anything you want. You could have mega balls, right? And that would just mean you had 1,000,000 balls. You could have a micro ball, which means you took 1,000,000th of this ball. That's fine. They're just a way of modifying any unit that you want. Now, why is it important to understand these? When I first made this lecture, I was literally typing up that last slide. I got bing from my email. And back in those days, there was this thing called Google Offers. And Google Offers was trying to sell you stuff because, you know, that's what Google does. Believe it or not, they try to sell you stuff. And they came up with this offer. It said, hey, here's $8 for 30 ml of shea butter hand cream. And I looked at that and I just laughed because what they were trying to sell me are ML with a capital M. And well, as I was doing that last slide, I knew that a capital M meant 1 million. And so what they're actually trying to sell me is 30 million liters of shea butter hand cream. That's millions of gallons of hand cream for only $12. Now, I was tempted to take them up on their offer, but you know, I was worried that if someone had a sense of humor and they actually delivered millions of gallons of hand cream to my house, I would have no idea what to do with it. So I didn't take them up on their offer. But you'll see it quite often that even though we have these prefixes, even though we try to use them correctly, a lot of times in the world people don't use them correctly, and so we just have to be aware of those things. Alrighty, so we're going to practice converting these things, and the easiest way is to set everything up like a conversion, like we've done in our class. We're going to put what we start with on the left, what we're trying to get to on the right, write our conversion factor, and then fill in the numbers. So if I start with 400 microliters, and I want to convert that into liters, I'm going to set it up just like I talked about before. So what I start with on the left, what I'm looking for on the right. Now, what do we have to do first? Numbers or units? Right, we always do units first in our conversion factor. So where do microliters have to go? Well, we've got microliters on the top. We want to get rid of them, so we better put a microliter on the bottom. And by the way, micro, when you're trying to write it, it's kind of like an M, but it's a little curvy. So there's an M, right? And micro's got these kind of little curves on it, and also a little more curved in the middle. And you can look up how to write these things. If you're somebody who has nice handwriting, that's good enough for me. But so we've got a microliter there. If we want liters at the end, we better put liters on the top here. And so we know that our units cancel to give us what we want. So we've got the correct units here, which is our first priority. Now we've got to get the numbers in there. And how do we know the conversion between liters and microliters? Well, anytime you're looking in this class and you see a unit and a unit with a prefix, we know we're going to be using those definitions that we have. And so if we look back on your chart, and I'm going to post the chart on Canvas so you can print it out for yourself. I highly encourage you to do that. Micro means 10 to the minus 6. And again, you can put micro in front of any unit that you want. And so what I'm going to do is I'm going to put it in front of liters, which means microliter is 10 to the minus 6 liters. And I'm going to put the 1 there explicitly. Right? When you just say microliter, you really do mean 1 microliter. And so here, I've got my conversion equality. Now you remember I can always make 2 conversion factors off of that, and so you could write down those conversion factors and then use the right one, or you could use that rule I said, which is numbers stay attached to their units. And so in front of microliters, I've got a 1. So up here, when I find microliters, what am I going to put there? I'm going to put a 1. And then in front of liters, I've got a 10 to the minus 6. So what am I going to put up here? I'm going to put a 10 to the minus 6. You type all that in your calculator is probably going to tell you this, 0.0004 liters. I'm going to go ahead and write that in scientific notation, if you remember how to do that. If not, good little practice, is 4 times 10 to the minus 4th liters. What did we do about significant figures here? Well, the starting number didn't have a decimal in it, so it only had 1 sig fig. These conversions here, when we're converting using the unit prefixes, are exact, and so we don't do any significant figure work with them because they have infinite significant figures, and so we end up with 1 significant figure in our answer, and that's 4 times 10 to the minus 4th liters. Go ahead, practice that, plug that into your calculator, make sure you can use your calculator properly to get the answer that I got. Next, I'm going to show you an alternative way of doing this exact same conversion. So I'm going to solve the exact same problem. I'm going to get the exact same answer, but I'm going to do it slightly differently. And the reason I'm going to show you this one is because the method that I do second here is the method that I'm actually going to use for the rest of the class when I talk about unit prefixes. You are welcome to do it either way. Some people are more comfortable doing it the way I just did it. Most people find the other way a little more intuitive, but it's not required by any means. So I'm going to do this. I'm going to start with 400 microliters. I'm going to go to liters. I'm going to put my conversion factor. Nothing changes up till this point. That's all the same. But what changes now is what numbers I put in. And you're like, wait, you can't change the numbers you put in. I mean, the numbers are the numbers, right? And like 10 to the minus 6 is just 10 to the minus 6, and you got to put that there. And to some extent, that's correct. But remember, numbers are just numbers. We can also manipulate them as long as we keep them equal to each other, right? I can say 3 equals 3. I can also multiply both sides by 2, and I get 6 equals 6. Both of those are correct. So what I'm going to do is I'm going to do this again. I've got 1 microliter is 10 to the minus 6 liters. Like, you're not doing anything different, but here I am. My next step is to do something slightly different. I'm going to divide both sides by 10 to the minus 6. And I can certainly do that, right? You can divide both sides by the same number, and you get the same number. So now what I've got is 1 over 10 to the minus 6 microliters is equal to, well, these guys cancel out and give me a 1 liter. Okay? Now, if you remember from algebra, if you have 1 over something, that's equal to something. You can also plug it in your calculator. Divide 1 divided by 10 to the minus 6, and hopefully you will get 10 to the positive 6. So I'm going to write this here. I encourage you to verify it for yourself. That you get 10 to the 6 microliters makes 1 liter. Notice the thing that's changed here is we now have a positive exponent. Micro is defined as a negative 6, but now we say we've got 10 to the 6 positive 6. What does that mean? It says I need a lot of microliters to make 1 liter, right? Because a microliter is tiny, it's a millionth, and so I need a lot of them, 10 to the 6th of them, in order to make 1 liter. So this is just a different way of writing it. It's exactly the same mathematically. By the way, I was just thinking as we were doing here, if I said, hey, why don't you plug this 1 times 10 to the minus 6 into your calculator, how would you actually plug that into your calculator? Because how do you write 10 to the minus 6 properly in your calculator so it will do those calculations correctly? Because remember, I warned you earlier that if you don't type in scientific notation properly in your calculator, it can screw things up. So how would I type that into my calculator? Well, what I would type into my calculator, so let me bring this down here into green. What I would type into my calculator is this, 1 divided by, and then I want 10 to the minus 6. So you could write 10 caret minus 6, and in this case it would totally work. But we're going to see these kind of numbers all the time, and I think another good practice is to realize that 10 to the minus 6 is the same thing as 1 times 10 to the minus 6, right? Because anytime you multiply by 1, you get the same number. And so here, I'm going to take, and I'm going to use whatever built-in scientific notation my calculator has. I'm using that lower, or that small uppercase e that the Texas Instruments calculators often use. And 1e minus 6. If you type that into your calculator will either say 1 million, and then you have to turn that into scientific notation, or your calculator might say 10 to the 6. Okay, so good thing to practice typing into your calculator. Also good to realize that whenever we have 10 to the power, we can write that as 1 times 10 to the power, and that's a good way of putting it into our calculator. Back to the problem at hand. We now have this relationship between microliters and liters. And so if I scroll back up to my problem here, I have space for numbers in front of liters, and I have space for numbers in front of microliters, but my numbers are going to change now. If numbers stay attached to their units, and I've got 10 to the 6th in front of microliters here, then I want a 10 to the 6th in front of microliters up here. And again, it's positive 6, lots of microliters, right? Remember, positive exponents are big numbers. Lots of microliters make up 1 liter. Why do I do this method? Do we do all this math that we did at the bottom? It seems like a lot of extra work to try to get to the exact same answer, because if you type this in your calculator is going to tell you 0.0004 liters, or 4 times 10 to the minus 4th liters. It's going to give you the exact same answer, and it seems like a lot of extra work to do all that math. And if you did all that math every time, absolutely it would be a lot of extra work, and it totally wouldn't be worth it. But here's the part that I think is intuitive for some people, is that since micro is small, I need a lot of microliters to make a liter. And you can use that logic in order to fill these in without having to actually write down the math every time. So the general rule, if you're going to be using this method, and like I said, this method is the one I'm going to be using as we go forward in the class. The general rule is this, is you put a 1 in front of the larger unit. So here, liters is larger than microliters, so I put a 1 in front of liters. And then you put a positive exponent in front of the smaller unit. Right. If it's always 1 to the larger unit, I'm always going to need lots of the smaller unit to make up that bigger unit. So even though we had micro, which is by definition 10 to the minus 6, we say, hey, I need a lot of microliters, so I need 10 to the positive 6 microliters. Let's do a few more examples down here of that. What about if I was trying to convert between grams and nanograms? What would I say? I'd put a 1 in front of the larger unit. A gram is a larger unit than a nanogram. And I'd put a positive exponent in front of the smaller unit, 10 to the 9th nanograms. A lot of little tiny nanograms makes up 1 big gram. This also works for the big units. If I was trying to convert between seconds and megaseconds, which is the larger unit. Right? Mega is huge, right? So a megasecond is a huge unit. It's a million seconds. And then mega is 10 to the 6, and so I put a 10 to the positive 6 here. Lots of seconds make up 1 megasecond. Okay. So it's a little weird because you always use that positive exponent, but most people can do that logically in their brain a little bit easier than they can do the writing that 1 and 10 to the minus 6, because those minus exponents are a little bit tougher to do mentally. It's tough to think about a millionth of something. It's easier to think about a million of something. Again, either way you want to do it, if you do it correctly, you'll get the right answer and you'll be okay. It's if you do it incorrectly that you've got a problem. So we'll practice with that one as we go forward. So let's go ahead and do a few problems. We've got 4 different problems here, and we're trying to convert the numbers to regular numbers without unit prefixes. So if we had gigaseconds, we'd convert it to seconds. So in the first one, we're going to take millimeters, and we're going to convert it into meters. This is a great time for you to pause the video, write these out, and try them. Plug them in your calculator to get a final answer. Remember, watching me do it is very different than you doing it yourself. Even if you make mistakes, even if you aren't quite sure what you're doing now, the actual act of practicing them, figuring out how you're solving it, and correcting yourself is actually the most useful way to learn this stuff. I make it look easy because I've been doing this longer than most of you have been alive. So, pause the video, try these out, then come back. Okay. I'm assuming you tried them all. It's a good assumption, right? Yeah? Okay, good. So 3.757 millimeters. And I said I'm trying to convert those out of prefixes, so I'm just going to convert that to meters, what I start with on the left, what I'm looking for on the right. I need millimeters to cancel, so it's got to go on the bottom. I'm looking for meters, so it's got to go on the top. Now, with meters and milli, it gets a little confusing sometimes with all these little m's, but we got to keep track of them. So what do? We put a 1 in front of the larger unit. Which is larger, a meter or a millimeter? Remember, a milli is 1,000th, right? A millimeter is a very small amount. Height of an ant, a meter is bigger than that. And so I put a 1 in front of the meter. And then milli, if you look it up in the table, is 10 to the minus 3rd. But in our way of doing it here, we're going to use a 10 to the positive 3rd. Lots of little tiny millimeters stacked up on each other make a meter. Plug that into your calculator. Your calculator will probably tell you 0.003757. I'm going to go ahead and convert that to scientific notation because I like reading scientific notation better. If I don't ask for an answer in a particular format, you could theoretically write either way. All right, how about the next one? We've got 1.99 mega years. And we're going to try to convert that into years because our problem was to get rid of our prefixes. What's going to go on the bottom? We want mega years to cancel, and so it's got to go down here. And we're trying to get years, so it's got to go up here. So what's bigger, a year or a mega year? Remember, mega is 10 to the 6. It's huge. And so our mega year is our larger unit here. And mega is just 10 to the 6. And so we need 10 to the 6 years, a million years, to make 1 mega year. Type that in your calculator. You should get 1.99 times 10 to the 6th years. Next one, 37 kilograms. And we're going to try to convert 37 kilograms into grams, because our goal in the thing was to remove the unit prefixes. Where does grams have to go? Well, if we're trying to get grams, grams better go on the top, because here it's on the top, right? Remember, when there's no denominator, it's kind of like there's a 1 in the denominator and grams is in the numerator. Kilograms is in the top here, so it's got to go on the bottom here. Always 1 on top, 1 on bottom. If you have 2 on top, they don't cancel. Even if you draw a line through them, they don't cancel if you have 2 on top. So which one's bigger, a gram or a kilogram? Kilo is 10 to the 3rd if you look on your list, so it is bigger. And I need a lot of grams, 10 to the 3rd, a lot of grams stacked on top of each other to make one big kilogram. Type that into your calculator. Your calculator will probably tell you 37,000 grams. You could also write that as 3.7 times 10 to the 4th grams, and you'd be okay. Last one, 0.357 micrometers. Now, 0.357 isn't a number between 1 and 1,000, so this isn't proper use of our unit prefixes, but it's allowable. It's perfectly allowable to write whatever number we want in front of a unit prefix, but when we say, hey, let's use these properly, we generally write a number between 1 and 1,000. So 0.3, for consistency's sake, let's use a new color here. 0.357 micrometers. Some people will say micrometers, and that's perfectly okay as well. We're going to convert that guy to meters, because that was our goal. Hopefully, you're starting to get where units go. The micrometer has to go on bottom, because 1 on top and 1 bottom cancels out. The meter has to go on top, because that's what we're trying to get at the end. How do we relate meters and micrometers? Now here we're doing a bunch of problems that are similar, but again, it's just good practice. When you see a unit and a unit with a prefix on it, then you know that you're going to be using these definitions. Which one's larger, a meter or a micrometer? A micrometer is a 10 to the minus 6, so a meter is going to be much larger in this case. And if you look at the definition of micro, it's 10 to the minus 6. And so we put a 10 to the positive 6 here, because that's the method we're using. A lot of little tiny micrometers stacked on top of each other makes one big meter. Plug this into your calculator, and you should get 3.57 times 10 to the minus 7th meters. Some calculators will write 0.00000 with 6 zeros and then the 3. I'm writing it in scientific notation because it's much easier to understand it this way. Be sure that when you do it, you are getting this minus 7 as your exponent. A lot of people think they should get a 6 because they've got a 6 here, but that's not the case, because this guy already is a decimal. So make sure you're getting that 10 to the minus 7th. What about if we have a number and we want to convert that number to be using our unit prefixes? So we've got 14,805,000. How are we going to convert that to be able to use our unit prefix? And it turns out the easiest way to do that is to write the number in scientific notation, because then you have a number between 1 and 10 and an exponent after that. In ideal cases, the exponent matches one of our prefixes. In non-ideal cases, we're going to have to move things around a little bit. So let's do just a few examples, because examples are always the easiest way. So we're going to start with 0.039 meters. And we want to convert that to using a unit prefix, which means we're going to convert it to megameters or nanometers or micrometers or whatever it is that's the appropriate thing to do. So the first thing we want to do is write this number in scientific notation. If you remember how to do that, we're going to move the decimal 1, 2, 3. It's a small number, so we should have a positive or negative? Negative exponent. 3.9 times 10 to the minus 3rd meters. And again, I think we said this before, but just as a reminder, when we are converting between numbers in decimal and scientific notation, we don't change the number of sig figs. We had 2 sig figs here, we have 2 sig figs here, and that's an important thing, is when you're just converting between decimal and scientific notation, you cannot change the number of significant figures. It's very important. 3.9 times 10 to the minus third meters. Well, what do we know? We know that 10 to the minus third is exactly the same thing as milli. They are entirely equivalent. So everywhere I write 10 to the minus third, I could also write milli. It's just like if you had 3x equals 5 and you knew that x, well, let's do 3x equals 6. You knew that x equals 2, right? It means I could write x or I could write 2 and it would be fine, right? I could write 3 times 2 equals 6. So I can write x or I could write 2 and it's the exact same problem. Here, I can write 10 to the minus third or I can write meters and it's the exact same way of writing it. And so I can just substitute that in. Instead of writing 10 to the minus third, I'm going to write milli. I said meters just a second ago. I meant milli. And I've got 3.9 millimeters. What I see students do a lot of the times is instead of substituting it, they add it and they write 3.9 times 10 to the minus third millimeters. And that's not correct. You're substituting. You're saying, instead of writing 10 to the minus third, I'm going to write milli because they mean the same thing. That's great. You don't just add it onto there. If you're a little uncomfortable with that, you could be like, okay, I know that milli is 10 to the minus third, and so I'm going to say 3.9 times 10 to the minus third meters, and I want to convert this to millimeters. And you can set up a conversion like this. I'm going to go through this one really quick. And it would look something like that. Meters on the bottom, millimeters on the top. Meters is bigger, so it gets the 1, 10 to the third millimeters, and you end up with 3.9 millimeters if you plug all that into your calculator. You can do it that way. I encourage you to try to be comfortable doing it this first way because it's a little faster, but it's certainly not wrong to do it the other way. And you'll get the same answer. All right, let's do another example. Let's go ahead and do, we want 4.9 times 10 to the fourth liters to use unit prefixes. Now, this is great. The number's already written in scientific notation, so we don't have to convert it to scientific notation. What did we do last time? We looked at this exponent. We said, hey, it matches one of our common exponents. And we look at this one and we say, hey, that doesn't match one of our common exponents. So we can't just substitute in milli or mega or whatever because 10 to the fourth doesn't match anything on our list if you go look at your list. So what do? Well, we use the fact that all of these scientific notation and all these prefixes are factors of 10. And when we do factors of 10, it's just like moving a decimal around. 4.9 times 10 to the fourth, what I'm going to do is I'm going to take this decimal point and I'm going to move it to the right. I'm going to make the number 49 here. Why did I move it to the right? Because remember, if we want to use unit prefixes, we want a number between 1 and 1,000. If I moved it to the left, I would have gotten 0.49, less than 1, which is not what I want to do when I use unit prefixes. So I've got 49. Can I still write times 10 to the fourth? I can't, right? Because here, this was 4.9 times 10 to the fourth. I can't now write 49 times 10 to the fourth. That would be a different number. So I made this one bigger by a factor of 10. What I need to do is I need to make this one smaller by a factor of 10. How do you make it smaller? You subtract 1 from the exponent. So now, since I made this 10 times bigger, I'm going to make this 10 times smaller by subtracting 1. And so I actually get 49 times 10 to the third liters. Now 10 to the third does match one of our prefixes, and so we're good. 10 to the third matches kilo. And so we end up with 49 kiloliters, and we can just substitute that straight in, or we could do it the math way, doing the conversion. Cool. So there we go. If we've got a number where the exponent doesn't match, we can go ahead and just move the decimal point to the right, change our exponent by subtracting 1, and then see what happens. What about in the case that that doesn't even work? So let's do one more example here. And we've got 5.35 times 10 to the minus fifth grams. 5.35 times 10 to the minus 4th grams. What are we going to do here? 5.35 times 10 to the minus 4th grams. Well, we say, hey, 10 to the minus 4th doesn't match anything we know. So I'm going to move my decimal point over 1. I'm going to get 53.5 times 10 to the minus 4th, and I've got to subtract 1. I made 1 10 times bigger. I need to make 1 10 times smaller. Always subtract 1. That's going to be 53.5 times 10 to the, what's minus 4 minus 1? Some people are tempted to write minus 6 here. I'm sorry, minus 3 here. Because you say, well, 4 minus 1 is 3. But minus 4 minus 1 is going to be minus 5. So make sure you understand that one. Go over it a couple times if you need to. Okay. So 53.5 times 10 to the minus 5, you go over to your chart, you say 10 to the minus 5. It ain't on my chart. Well, if it's not on my chart, what do? I do the same thing. And you'll never have to do it more than twice. Since all of our numbers are separated by powers of 1,000, you'll never have to do this more than twice. But in this case, we do have to do it a second time because our exponent didn't match. So we now have 535 times 10 to the minus 5th, but we've got to subtract 1 from that. And so we get 535 times 10 to the minus 6th grams. Okay. So every time we move the decimal point to the right, we need to subtract 1 from our exponent. But now a 10 to the minus 6 does match something in our table. It matches micro. And so we get 535 micrograms. So 535 micrograms. Total aside here, for a lot of you, you're going to be going into health fields. Micro, if you remember, most doctors don't have great handwriting, right? And micro and milli look awful similar when you're trying to write things out. So if you're not really careful about your micro and your milli can look very similar, especially if your handwriting's not so good. So what you'll actually find quite commonly in the health field is instead of writing micrograms, you will see people write mcg. Now, technically mcg is milli, which is 10 to the minus 3rd, and centi, which is 10 to the minus 2nd, and grams. So it's millicentigrams. If you do that out, 10 to the minus 3 times 10 to the minus 2 is 10 to the minus 5th grams. And that's not the same as micro. A millicentigram is a valid unit. You can put milli in front of anything, even centigrams. However, it's not equal to a microgram. However, it is used in the health fields quite frequently as a substitute for micro. So just be aware of that. Even though millicenti does not equal micro, it is used as a substitute for micro. So when you see mcg on something, it actually means micrograms. Alrighty, just a few more to try here. We're going to convert each of these numbers into using unit prefixes. Again, what I highly encourage you to do is pause this video, go ahead, write out those numbers using unit prefixes following the method that we did, convert to scientific notation, check your exponent. If not, move the decimal point to the right, subtracting 1 from your exponent every time you do that. Pause the video, try it out, because that makes all the difference. You doing this is what actually makes it work for you. You watching me do this does not make it work for you. You're back. Okay, how'd it go? Was it good? Okay, glad. I'm good to hear that most of them went okay. Awesome. All right, let's try. Let's see how you did. 0.00374 joules. I'm going to write that out as 3.74 times 10 to the minus 3rd joules. And you're like, I don't know what a joule is, Professor. Doesn't matter. I can put it in front of any unit I want, even ones that I have no idea what they are. Doesn't matter. Okay. We'll learn what a joule is later in the class. 10 to the minus 3rd does match milli. They're the same thing. So I can substitute in milli for 10 to the minus 3rd and keep this the same. Now, you'll notice I don't write the times here. I almost did just out of habit. I don't write the times here. I just write 3.74 millijoules. There is implicitly, this is actually saying the same thing as 3.74 times milli times joules. Okay, that's what it means, but nobody actually writes it like that. They just write 3.74 millijoules. Here we've got 1,387,000 seconds, 1.387 times 10 to the 6th seconds. And if you remember, 10 to the 6th is mega. And so we get 1.387 megaseconds. Another thing about these conversions with unit prefixes is just like converting between decimal and scientific notation, you should never change the number of significant figures. So if I start with 4 sig figs, I should end with 4 sig figs. If I start with 1, I should end with 1. 8.27 times 10 to the minus third gram. This is the easiest so far. We already gave it to you in scientific notation. This one's already in a unit that we know that exists. It's milligrams. This is 8.27 milligrams. Now, notice my handwriting. My handwriting is not great. I can't tell whether this is a lowercase m or a capital M the way I wrote it. So I'm going to go back and I'm going to correct this and try to make sure that my M is small. There are people out there who love to write in all caps all the time. If you write that, people are going to think that you mean 1,000,000 grams. And so you do have to write this guy as a small m. My difficulty is that even when I write a large M, I tend to make it just a bigger small m. Good practice in this class is to write your capital M's in a slightly different type of script. Here, block script as opposed to more of a smooth script so that people can distinguish it. 6.27 times 10 to the 8th K. Remember, K stands for Kelvin. It's a temperature unit that we'll talk a lot more about in the next chapter. What do we do? 10 to the 8th doesn't match anything on our list. So what are we going to do? We're going to move that decimal point 1 to the right. 62.7 times 10 to the 8 minus 1 Kelvin, or 62.7 times 10 to the 7th Kelvin. Still doesn't match anything, so I'm going to do it one more time. I've got 627 times 10 to the 7 minus 1 Kelvin, which is 627 times 10 to the 6th Kelvin. 10 to the 6th does match. It is mega, and I've got 627 mega Kelvin. So you can see, again, my handwriting is not great, but I tried to make that M a little bit bigger. One last one, 4.2 times 10 to the minus 5th meters. 10 to the minus 5 doesn't match anything on our list. And so we're going to go ahead and move that over, and we get 42 times 10 to the minus 5 minus 1 meters, which is the same thing as 42 times 10 to the minus 6 meters. 10 to the minus 6 does match micro, and so I get 42 micrometers, just like that. So those how we convert numbers from regular numbers or scientific notation numbers into using unit prefixes. Our goal is to get a number between 1 and 1,000, not outside of that range. Here's one for you to try. What's the same thing as 18 nanometers? How many meters is that? So pause the video, try that one out, and see what you get. Alrighty, 18 nanometers, try to convert to meters. What goes on the bottom? Nanometers. On the top, meters, right? For nanometers, I need 1 on top, 1 on the bottom. Which is bigger, a meter or a nanometer? Nano is 10 to the minus 9, it's a tiny number, so a meter is bigger. But then we say we need lots of nanometers, 10 to the positive 9th. Lots of little tiny nanometers stacked on top of each other to make one big meter. If you plug that into your calculator, you should get 1.8 times 10 to the minus 8th meters. And it would look something like that. For those of you following at home, you're like, shouldn't that be 10 to the minus 9th? Because, you know, I just have it in the denominator. It should be 10 to the minus 9th. No, because you actually have to type these into your calculator. It's okay to use your calculator. But it turns out, right, 18, if you put that into scientific notation, is 1.8 times 10 to the 1. And so that's why you end up with that minus 8, because 1 minus 9 for those exponents is minus 8. All right. What about when we are trying to do conversions of these prefixes where it's not one step? If we're trying to convert, say, 187.38 micrometers into kilometers, if you go ahead and write that out as a conversion, again, it's never a bad idea just to write out your conversion and see what you get. I get my micrometers on the bottom. I get my kilometers on the top. Those guys are going to cancel. 1 on top, 1 on bottom. I get kilometers like I expect. tired of hearing that yet? Good. The more tired you are of hearing it, the more it means you understand it. And you're like, ah, of course I know that by now. Okay. So 187.3, then you look at those numbers, you're like, kilometers and micrometers. I don't know. And it's okay. Because remember, when we look at a conversion, we go, I have no idea what to do with that conversion. I don't know that conversion. There's a chance it means that we have a multi-step conversion in front of us. So we ask ourselves, what do I know how to convert micrometers into? And in general, any unit with a prefix on it, what we know how to do is we know how to get rid of that prefix. So I know how to convert micrometers into meters. Remember now that we're doing a multi-step, we're going to do a plan. What are we going to do? What's our plan in converting this? Now, once we're in meters, do we know how to convert meters to kilometers? Yes, we've been working on that for the last half an hour or so. So we do know how to turn micrometers into meters, and we know how to convert meters into kilometers. So that's our plan. Remember, each arrow in our plan is a conversion. So I'm going to do 187.3 micrometers. I've got arrow number 1, arrow number 2, and I've got kilometers on the right here. What's going to go in my first conversion? Well, I need to get rid of micrometers, so it's going to go there. My first arrow tells me that I'm converting that into meters. My micrometers cancel. 1 on top, 1 on bottom. Just because you draw a line through it doesn't mean it cancels. It has to be 1 on top, 1 on the bottom. Now, in my next one, I'm going to convert meters to kilometers, which means I need meters to go away. 1 on top, 1 on the bottom. And I need kilometers on the top, so I get kilometers at the end. I've got my units right. Now I can put in numbers. What's bigger, a meter or a micrometer? Micro's tiny, and it's 10 to the minus 6, but I need a lot of tiny micrometers stacked up on each other to make one big meter. Kilometers and meters. A kilometer is bigger in this case. Kilo is 10 to the third. It's a lot, so I need a lot of meters to make one big kilometer. I need to stack meter, 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 meter to get this big thing called a kilometer. You put that into your calculator, excuse me, and what do you get? You get 1.83 times 10 to the second divided by 10 to the sixth divided by 10 to the third. Okay. So what do you end up with? You end up with 10 to the, excuse me, that's a 6 plus 3 is 9. 2 minus 9 is minus 7. 1.873 times 10 to the minus 7th. Now, I did this in my head just because I could, but you're certainly welcome to do that in your calculator. In your calculator, you type in 1.873 times 10 to the 2, which you'd use that E notation, whatever your calculator likes. Remember, 10 to the 6th I can write as 1e6, and 10 to the 3rd I can write as 1e3. And hopefully your calculator gives you 1.873 times 10 to the minus 7th. It might tell you 0.000000000, I don't know, 6 zeros, and 1, 8, and 7, and maybe it'll show you that 3 there, maybe it won't. Okay? So be careful that sometimes your calculator will chop off digits that you need. Here we have 4 sig figs. We better have 4 sig figs that we start with. Gives me 4 sig figs in my answer. If your calculator, let me go ahead and write that out. If your calculator gives you 5, 6, 7, 8, 9, a lot of TI calculators will write the answer that way. That's not right. That's not the right answer. Just because your calculator only gives you those digits doesn't mean those digits are the right digits to have. You need to have 4 sig figs. It's really useful on your calculator to understand how to convert your calculator to tell you all the digits that you need. Most Casio calculators, other brands of calculators, they do this just fine. They know how to convert and when to convert to scientific notation. TI doesn't quite get it right. They will keep things in decimal notation until they only have one significant figure, and then when they're forced to, they will put things into scientific notation. I don't have my camera set up right now to show you calculator, so I'm just going to hold it up to the screen here. But let's say I had that answer in front of me. I had 1, 2, 3, 4, 5, 6, 1, 8, 7, 3, and my calculator was just showing the 187. But I'm like, I know there should be more significant figures in there. One thing you can do is tell your calculator, can you please show this number to me in scientific notation? And your calculator can do that. How you do that on the TI calculator is if you look on top of there's a second key on the top left, and right above that, or right next to that, there's a key that says DRG, and above that in blue it says sci-eng. And so I'm going to put that up here, and here's my second key, and here next to it is the DRG key that says sci-eng. What I'm going to do is I'm going to press the second, I'm going to press the sci-eng key, and now it gives me a list of flow sci-eng. I'm going to use the arrow keys, and I'm going to tell it sci, which says put this in scientific notation, please. And when I hit enter, it actually gives me the answer in scientific notation, which is 1.873 times 10 to the minus 7th. And so I can actually get those digits back that I know I'm supposed to have. So be aware of that, especially if you're using the TI calculators, that they really play loose with these small numbers, and you sometimes need to convert it. Now, the problem is, now your calculator is in scientific mode. So I typed the number 23 in there, and it's telling me, oh yes, that's 2.3 times 10 to the first. And that's annoying, because when you're just trying 23, you want the calculator to say 23. So what you do is you do the same thing, but we're going to switch back out of sci mode. So we hit the second DRG, and we're going to convert back to floating point mode. So FLO, which is regular mode, and now it tells me 23. So good thing to know how to do on your calculator if you've got one of the TI calculators. Like I said, most other brands do that a little bit better. There we go. I'm like, it's not wanting to go to the next page. So if you want or need more practice, and most of you will, these conversions with unit prefixes usually take people a while to grasp. I have a website, it's professorclements.com, and in the introductory chemistry section, there's an online practice part that will give you single-step and two-step metric conversions until the cows come home. It makes up a brand new one each time. It's not just a list of them, and it makes up different numbers of significant figures and different conversions. And so you can literally do this all day long until you get comfortable with it. What I recommend to people is literally go and do 40 of them. The first 10 will take you a long time. The second 10 will take you a little bit less time. The third 10 won't take you much time at all. And the fourth 10, you'll be like, just going through them. Not quite that fast, but really fast because you'll have the pattern down. But if you do 40 of them, you do 50 of them, and you can get to where you're getting all of them right, that will be really helpful as we move forward. What it looks like is it'll give you a problem. It'll ask for the answer. If you need to put in scientific notation, you can use that E notation. So let's say you needed to put in 4 times 10 to the 5th. You can write 4E5. You can also write 4 times 10 caret 5. It'll accept either way. This way is a little more compact. You can also write it in decimal form if you want to as well. It'll check your answer, and then it'll also tell you the answer. And if you want it to, there's a little button that says show the solution. It'll actually show you how to set it up. So here we were converting teraliters to liters, and it says you need 1 times 10 to the 12th liters on top. You need a teraliter on the bottom, and that gives you your answer of 2.72 times 10 to the 14th liters. So I really encourage you, go here, practice those single step ones first, again, like 40 of them, 50 of them. Then move on to the two-step ones. Those ones maybe not 40 or 50 because they take a while, but maybe like 20 or something like that until you get to the point where you're really comfortable with them. The computer will let you do it all day long. It'll never tell you you're a bad person for doing too many of them, and it won't get impatient with you. So, good resource. Encourage you to take advantage of it. Sorry about this extraordinarily long video. I think it's the longest one of the entire semester. I try to break things down a little bit more, but this was one kind of big topic about these metric prefixes and how to use them. Thanks so much for listening. Bye-bye.